Thanks for being here. Well, first of all, congratulations to the Portuguese. 50 years ago, they discovered, they started the democracy here, so they are celebrating this. So congratulations for the Portuguese for today. Yeah, so this is we're talking about the heat reuse subproject. It is a subproject under the cooling environments, and we are here, 3 of us. I mean, we are 2, 3, 6, 8 people in this workstream, in this subproject, actively working, and we are 3 of us here. So it's I think it's great news that we managed to come here, all of us, and we're going to show our work this past year and what we're going to do in the coming months. So I'm Jaime Comella. I'm from Compute. I'm co-lead of this subproject together with Barath from Microsoft. He's in the US. And we have, as I said, so David and Peter, who are here, from Policies and Economics Workstreams. We also have Otto, Jack, David Sickinger, and Mark Smith, who couldn't actually join us. So the heat reuse subproject was developed to gather experiences about what has been done around heat reuse, what can be done, and generate a guidance path for the data center companies, for vendors, for technology vendors, that want to develop a project of this kind. We have calls every month for the different work streams, and a general call also every month. Here you have a fantastic QR code for our wiki page where we have a lot of information and access to the guidance that we have already done, have already created, and also a QR code for the calls. So we have so far developed a heat reuse map where we have located all the projects with waste heat recovery. The blue dots are the ones that have been done already, that are finished. The red ones are under completion. This map is not possible without data from the industry, so we actually ask everyone to give us the data. If they know there is a data center with heat reuse that is not there, please let us know. If you click on the dots, you have a spreadsheet behind with a lot of technical data. We would love to have this really completed, but it's been difficult to get this data from the industry. We have done also a Heat Reuse 101, which is a white paper that we have written 9 months ago. It's the first approximation to this topic, and I recommend you to download it. And we are going to present today our policies to accelerate data center heat reuse white paper. And I will leave, actually, David to explain that. And with this, I'm giving the microphone to my colleague. So this is the heat reuse guidance path we are actually building. We have done already a couple of white papers. We are thinking about, we are already working in the next 2 white papers, the reference designs white paper and the economics white paper. We will focus on how does this heat reuse exchange room needs to look like, and how does this can cost. We also have the map. We are building a database of data centers. We're building a database of policies around heat reuse as well, and potentially a matchmaking platform where we want to collaborate to bring together data centers that are giving heat away and industries that need this heat, this precious heat. And we are also building a set of tools, analysis, calculation tools for let's say reference designs and also economics evaluation. And all this will be let's say packed into an assessment path. We want to build a gap analysis assessment for data centers. We want to see how far they are of developing heat reuse projects, and in the end, after they have actually gone through our guidance path, to see how far they are to be heat reuse ready. Yeah, I give the microphone to David.
Great, thank you, Jaime. I am going to talk a little bit, this will be a rapid tour of the policies paper that we have just put out, but we encourage you to download it yourself and to read it to get more of the detail. I want to thank all the people who participated, which certainly included Jaime and Peter, but we really had about 15 people who made contributions to the paper. It was a good example of OCP projects. So there are four major parts of the report. The first lays out the opportunity to reuse data center heat and makes the case that for both the data centers and for end users, that data centers, both economically and environmentally, a smart idea. Data centers obviously can monetize the sale of the heat, cut their power costs, and cut their carbon emissions. End users, of which we think there are many in both the industrial and commercial settings, can both cut their costs and their carbon footprint. We identify, as have been done in some previous papers, some of the potential end users that you can see listed here again in both commercial buildings and industrial settings. We note that there are challenges to data center heat reuse, and that part of the reason we're examining policies is because policies can help overcome those challenges. So there is a lack of knowledge and awareness of this opportunity, even within the data center community, but potentially much more broadly, certainly by potential end users, and very much so from policymakers. You're all familiar that heat does not travel very far, so a lack of proximity and connections between data centers and heat users is an important aspect. There can be discrepancies between the supply of the heat and the demand that are needed. Some of that is seasonal. There are other ways in which there can be discrepancies. Many of these heat reuse projects face risks and costs associated with project development. And a further challenge is that there really are very few policies, either at the national or maybe at the supranational level here in the EU, as well as at the subnational level. So then the bulk of the report is what I would describe as a non-exhaustive list of policies that we've identified in both Europe, North America, and a few in Asia. It's not designed to be a comprehensive list of everything. We thought it was useful just to identify some of the things that have been started around the world. We've sorted them into three sets of actions or types of actions. There are what we think of as standards and requirements on data centers to reuse heat. There is a category that has too long a title, analyzing possible uses, sharing information, and promoting collaboration. I think of that as sort of the encouragement, the connection kind of category. And then there are tax and other economic incentives. I think it would be safe to say that the EU is far ahead, as you are on so many things, of North America and the rest of the world. And then I'm just going to provide a few examples of some of those policies, some of which I suspect many of you are already familiar with. So in the standards and requirements category, Germany has adopted its Energy Efficiency Act, which establishes not just broad energy efficiency requirements for existing data centers, but heat reuse requirements for new data centers, so that new data centers in July 2026 must have reuse a minimum of 10% energy. That increases over time, as you can see here, 15% in July of 2027, and a minimum of 20% in July 2028. Those are requirements on new data centers. It's not as if that scales up with an existing data center. This category of promoting collaboration, again, the EU is far ahead. There is an EU heat and cold matching platform designed to connect up, as Jaime was referring to earlier, people who can generate excess heat with potential end users. It's not limited to data centers, but data centers certainly could participate and find potential end users. It includes looking at other energy-intensive industries who may wish to reuse their excess heat. And at the national level, Germany, Ireland, and Norway have developed similar systems, some of those the ones in Ireland, for example, very focused on data centers where there's a particular focus on this. There are incentives available, financial incentives in Washington State and the United States. They have an industrial symbiosis program which provides grants for research and development of waste heat coordination projects. Again, that's a broader category than just data centers, but data centers are very much a part of it, and financial grants are available. The German government has established a fund for decarbonizing district heating, money available through 2026 to decarbonize district heating, and so that could potentially be available for a data center. And then the final section of the report is really where we have our call to action. Again, it's related to the fact that I mentioned earlier that there's a limited awareness here, but we believe that policymakers, others in the data center industry, intermediaries, organizations such as utility companies, and certainly potential end users in the commercial and industrial sector should come together to work with us to advance these policies. And we call on people from all of those communities to join with us, to work with us. And so that's sort of where we stand as of today. And we hope going forward that we'll be engaging with those various stakeholders, tracking new policies and building a database, and beginning to engage in with policymakers and advocating for more. So that's the quick tour of the 4 main sections of the report. And again, you can download it, and I encourage you to read it. I think I'm now over to Peter.
Oh, thank you. So, hello, everyone. In the interest of time and to allow time for questions, I'll try to make this short and sweet. And the white paper is actually the first, it's inaugurated today, I think, or, well, so it's fantastic news. The heat reuse economics workstream, led by myself and also Jack Koller from Houston, Texas, is one of the co-leads. We're currently working on a few projects. We're very output-oriented. So an Excel tool for collecting data, web-based tools for potential stakeholders, and those are the things that I'm going to show you right now. The white paper is still in progress. So Jack has put together a substantial database for HR economics calculations. The main resources have been the heat reuse projects map that Jaime showed us earlier, and also the Bytes to Heat project by Benjamin Ott at Stuttgart University and friends. The database is right now used to create a set of tools, and with intended users like data center entrepreneurs, policymakers, and also engineers, but not mainly engineers. So here's a data dictionary for heat reuse projects with over 300 different entries, and you can see, for example, the energy reuse effectiveness factor, heat reuse effectiveness, and so on. And it is a very, very useful output, I would say. It's also the backbone of our system and uses structured performance data. Then we have the database of heat reuse projects. So over 100 different projects, some of them already executed, some of them planned, also based on performance data. And this is a huge database with many, many columns. Then right now, we're transforming these Excel tools that Jack has created into web-based tools so that it will be more accessible for policymakers, especially. And that is under development right now, actually by my engineering students. So right now we have tools for internal data, for external data, and for AI-based data center placement. So the call for action, well, we do have the tools They're quite powerful. However, we do need more performance data. So if you have access to such data and you're willing to share them, then please come forward. The timeline right now is, well, the Excel tools first version are almost there. The web-based tools will be available this summer. The white paper will hopefully be presented at a global summit, and if not, a little later, and we'll also showcase the web-based tools during the summit in San Jose. And that will likely be Jack rather than myself, since he's part of the US market. And with that, Jaime.
Thanks, Peter. So because David and Mark are not here, I'm just presenting their part. So to close the circle, now are the reference design. So this is more about putting together drawings, a list of components that have to come into this exchange room, heat exchange room, and putting together also this, at the end is a guidance for engineering companies and for data center companies to know how this exchange room has to look like. Not only how much does it cost, but also how does it have to look like. We also have a diagram, a standard diagram is, of course, this diagram will be different from case to case, but at least this is like the base of the pizza, right? And then everyone can add on it. And also we have a nice table to see how big this heat reuse exchange room or heat reuse room will be, right? Based on different parameters that we are predefining, we see how big, how much space has to be reserved in the data center for this, for the new build or for the future or for even a retrofitting. So it's about giving an idea to people that are new into this. And finally, we have a dimensioning tool for this piping, these valves, and so on that we are developing. And it will be, of course, coupled with the tool that you just saw from Peter, so the economics. In the end, there are different work streams, but they're working together, and only working together we can show very nice results. Again, the call to action: join us, bring your data, bring the cost of your equipment if you are vendors. Bring your experiences. This is open to everyone, and yeah, we need people. I mean, we are very, very ambitious on making something very useful to the industry, and you're more than welcome to join that workstream. And finally, so to close the whole subproject, yeah, do you have some data center that is it's not spot on the map, but should be spot? Please come to us, tell us, join us in our calls, and well, having said that, if there are any questions, feel free to ask. No,
yeah, so just earlier they were talking about lower operating temperatures now, right? 25 to 30 C for what they're going to be requiring for chips. That's almost inverse in terms of what we would want to see for heat reclaim. So as you guys look at and as you're kind of interacting with some of the other groups at OCP, how do you see this impacting heat reclaim long term if we're going to be driving temperatures from where they are today and to 50 to 70 C down to 25 to 30 C? Thank you.
Thanks. That's a fantastic question. Actually, we're seeing that temperatures are getting lower, as you said, but this is like a roller coaster development, right? I mean, we'll bring in then liquid that we'll be able to bring the temperatures higher. At some point, physics will beat us. We'll have to go down. We have to bring the next development, so maybe microfluidic cooling will push that farther and so on. So there will be, at least for a time, until we change the paradigm of hardware totally, there will be an evolution for reaching high temperatures. And then we're also looking into opening a new workstream for how we can maybe condition the development of hardware to make this temperature to rise higher levels. So how we can condition this development and having in mind that we can generate a value, which is the excess heat that can be even sold. So this is still in the bake, so this workstream. So I welcome you if you want to contribute to this. But Bharath and I, since also his background is a lot cooling of hardware, we are trying to put a workstream on this as well. So fantastic question. Thank you. Here. Michael, just pass the microphone maybe.
Thank you very much. The key is not, if you're controlling around the output temperature, is different than what we've been trying to do in the past. Right now, we're trying to just get rid of the heat any way we can. But if the goal is to achieve a temperature at the end you can control around that, by managing the way you manage the fluid through the process and the other components. The key question is, how do you make sure there's headroom between the throttling temperature of the processors and the operating temperature you're trying to achieve at the output of the server?
Yeah, thanks, Herb. Yeah.
Actually, I'm going to pick up from that. Your model, both the economic model and your design model, shows what we talked about as maturity level 1, just a heat exchanger. But we could also potentially model in the economics of a heat exchanger and a heat pump. And so that would be something we might want to see in that model. And actually, in response to the other point that was just raised earlier, the key thing here is I do believe as customers, providers of technology solutions, as customers of these chips, I believe we have a right and an obligation to inform the chip manufacturers that we don't like the direction they're going in.
Feel free to do it. About the heat pumps, yeah, definitely. This is something I didn't mention because I wanted to be as organic with the answer as possible. But of course, I mean, we'll have then a panel. You're all invited after lunch, so it will be here as well. And we have Pauline in the panel from Euroheat and Power. We have also a guy from Danfoss. We have John Summers, and we have a guy from Conapto, from a Swedish data center with a lot of experience on heat reuse as well. So we'll have also the occasion to pose those questions probably. Are we going to need to boost always the temperature at some point? Maybe yes. I mean, we'll have to have a look to that. Next generation district heating networks are going into another direction. Maybe we can live with low temperatures. So there's definitely field for research in this. And I don't know, I mean, I think we run out of time, but if you want to pose more questions, let us know. Otherwise, thank you very much.